to the Reimagined Energy podcast. Today, we're exploring a topic that's reshaping the way we think about offshore energy. That's carbon capture and storage. Noble, a global offshore drilling contractor, is stepping into this space in some unexpected but fascinating ways, from adapting rigs for CO2 storage to developing new well control technology. They're showing how offshore expertise can accelerate the path to net zero. Let's dive into the conversation. Hi, Zach. Thanks for joining me today.
Hey Maria, thanks for having me on. Really excited to talk about offshore carbon storage today.
Exactly. I'm relatively new to this topic, and I'm sure, there may be some listeners who may be new to the topic as well, but let's paint the picture, like the big picture of carbon capture and storage. And that's also known, I guess, as in the industry as CCS. But if you can tell everyone like what it is, why it matters for reaching net zero and how offshore reservoirs, like your company, that you do, how does that fit into the story?
Sure. So
Yeah.
let's take a really big bird's eye view of like what CCS or carbon capture and storage is. CCS is a tool for decarbonization. When you look at the lay of the land when it comes to emissions, a lot of that is in power generation, and there's a good chunk of that that's in industries, like heavy industries. Making cement is one that's really interesting. For about every ton of cement you make, you actually make a ton of CO2. So it's like 1 to 1. There's other ones like steel making, really heavy furnaces and other industries. And a lot of it comes from like chemicals facilities, like processing, making all the plastics and chemicals we use day to day. These are all processes that require a lot of emissions just by its like general physics.
Right.
What CCS is uh, it's kind of like one of the choices that a lot of these industries will try to electrify when they can, and use renewables for that. But sometimes you just can't do that. It's actually cheaper to capture the emissions from the process,
Right.
and you capture that. You then transport it either by pipeline or vessel to a final location, and you actually store that in the ground. So imagine, if you have your car, it has its own tailpipe. If you just like capture that tailpipe emissions and you found a place to store it
Yeah.
forever in perpetuity. So that's what CCS is, and hopefully in the end, I think we'll have a part to play in the overall decarbonization journey. We won't be the bulk of it. Again, electrification is the first one,
Hmm.
but when it gets to like that last like 5 to 25%, CCS is going to be the card we play in order to get there.
So CCS might not be the first thing people associate with a drilling contractor. So why does Noble see a place for itself in enabling carbon storage? How to do your rigs and engineering expertise? Like how do, how
Yeah.
how does it make these projects possible?
It is pretty cool. I
Yeah.
find myself like extremely lucky that I'm actually at a legacy oil and gas company and I get
Yeah.
to have conversations with you or kind of work within these things. So, what is a driller even doing with this? So,
Hmm.
if we're talking about carbon capture and storage, a lot of the tech is around the capture side, a lot of the challenges around the transportation side. But when it does get to final storage, you are pumping the CO2 in the ground through a well. And if you think about like what my job is, it's not so much like oil and gas per se.
Hmm.
What we do is we drill wells. So we drill accesses to reservoirs. Most of the time, it's to get hydrocarbons out. But now we're flipping the process, and we'll be pumping CO2 down from the wells that we drill. So we're an offshore driller, so we have a fleet of offshore rigs. So we
Hmm.
own these giant floating islands that can drill these wells. Uh, when you look at offshore carbon storage, it's going to have a part to play in the overall storage landscape. It's probably going to be anywhere from, 30 to 50% of overall carbon being stored will be done offshore. The reason for that, the best thing offshore has is vast storage capacity. 70% of all
Wow.
land is that not land, but the Earth's surface is covered with ocean. And one of the great things it has is it's near industry. A lot of industry and facilities are on the coastline, uh, but there's nobody living above it.
Hmm.
So it's near it, but it's also far enough away to be in that kind of Goldilocks zone of, you can have access to a lot of the land and you can start getting that storage done.
Let's talk about, the drilling and the well control technology that's involved. So, what new systems or method, has Noble developed to drill or intervene, the CO2 wells safely? I mean, safety is huge, but
Safety is paramount.
how do these differ from conventional, oil and gas? Like,
Sure.
how does that all
Uh,
work?
so there's kind of two eras that we see it when it comes to these wells. It's first to probably good to highlight what these wells end up doing. So
Hmm.
you're going to need to drill an injection well to actually pump the CO2 down. And a good test case is that like every million tons of CO2 that's being captured will need its own injection well.
Hmm.
Uh, so in the industry, we're going to end up in an ecosystem where globally within a decade, there's going to be hundreds of these injection wells, both offshore and onshore. And then for every about like four injection wells, you'll need a monitoring well to monitor the reservoir and make sure the CO2 is downhole. These drilling campaigns have like two segments. So there's pre-CO2 being injected. So this is where it's just a clean reservoir, it's never been tapped into it before. You drill an injection well, or you drill a well that's going to be an injection well.
Hmm.
Honestly, these wells have already been drilled. Several out there. Our competitors have. These drill wells have been drilled on land. Pretty standard, couple thousand feet to your reservoir, pretty much vertical all the way. Where things get interesting and what we're, kind of specking up for is once CO2's been injected into the reservoir, you never have to re-engage with it, either by doing an intervention on an injection well,
Hmm.
or you do an infill drilling campaign, which is when you drill more injection wells into the same reservoir because we've captured more CO2, which is awesome. You will now deal with CO2 as a downhole component, which is pretty new for the industry. CO2 is different than hydrocarbon in several different ways. The first one, downhole, is it's far stickier in the drilling fluid than traditional hydrocarbons. So if you were to like tap into the reservoir, its influx is going to give off different signals to my drilling crews, and it's going to be a lot harder to detect because it's just going to be really seamlessly like sucked into that drilling mud. It's going to find the places in between the drilling fluid and just be really sticky. So it's going to be hard to detect. And by the time you detect it, you've actually had more CO2 influx than a traditional hydrocarbon kick. So even like in the basic physics of it, it's different. Once you start dealing with like how it flows through the system, if you had to process it, every step is pretty unique. So as you circulate it topside, if you have to, because you have to handle the kick, it's going to do something where it actually is going to do a phase change. So you store it in what's called a supercritical physics state, which is when it's like has high temperature and high pressure. So it acts as like a liquid and a gas in a way. It's like a mix. Eventually, you get to a point where the pressure in your wellbore decreases enough that it's going to change from supercritical to gas. So it's just like your water evaporating, right? It's phase change. This phase change has a corresponding 500x volume expansion because gas is just a way that this is actually something that happens like pretty quick. It's like it is and then it isn't. So here you are, you get this, this kick, and then all of a sudden it expands 500x in your wellbore. So that's a pretty like nasty phenomenon to deal with, right? Like
Yeah.
you have to deal with the handling of that. You got to make sure you maintain pressure, uh, as well as physics is a nasty thing. There's only so much energy in that kick, and that it expands in volume, so you get a corresponding temperature drop. So all of a sudden, you go from like a normal thing, and then next thing you know, it's like negative 50 Fahrenheit or whatever, which is like really freezing, and it's like lower than what most traditional systems are rated for. So you have to like upspec that. And then as you work it, like the CO2 is now gas. Uh, so when you do your traditional vent systems, most of the time you just like pump that off the top of your derrick. It's like methane, right? It floats away.
Yeah.
CO2 is actually heavier than air. So if you released it off the top of your derrick, it would actually settle on the drill like floor and on your cruise. And CO2 is toxic at high enough percentages. So once you have like 2 to 3% of the ambient air being CO2, it actually like gets when you breathe it in, it actually like replaces O2 when it meets
Wow.
your blood cells.
Wow.
So at a high
Huge.
enough percentage, yeah, no, this stuff will make you pass out,
Yeah.
and you can die within like 30 seconds or a minute, high enough one. And guess what? If you ever see one of my rigs, it has a
Yeah.
ton of enclosed space. So I
Oh.
mean, if the CO2 settles in one of these drill floors and my guys are there, like, no, that's a
Yeah.
real tier one danger.
Yeah.
So if you work all through that, it's like, oh, cool. You kind of have to like start from square one and figure out what to do. So what we've done is we've actually developed what we call an electrical CO2 enabler system,
Hmm.
which is like you put a diverter valve below your traditional BOP. So if you do have a CO2 kick and you do have to process it, you switch over to do this new system and you divert the CO2 so it never goes to your traditional systems. And you have a new CO2 grade system over here off the side,
Hmm.
processes the CO2 and then safely discharges it. So we've designed that, and that's like my full-time job. So right now we're launching a joint industry project with a bunch of players. We're making an ecosystem, and the goal is to get the first system designed and built by 2029. So it's there ready for the offshore carbon storage hubs that are coming online like right now.
Wow. How are you collaborating with OEMs and research institutes and storage operators to create, equipment and standards, for CO2 operations?
Yeah, no person can do any of this alone. Like
Yeah.
if I talk
Mhm.
about this, there's a ton of players here.
Takes a village.
Uh,
Yeah.
it takes a village. So for OEMs, we've reached out to them. We are figuring out where to go from X to Y. CO2 is like not crazy. If you drink a Coca-Cola, there's CO2 in it, right? Like we handle this. These things are
Mhm.
known. We just have to reapply them to well control equipment. So we have some great relationships with our well control vendors. We've signed development agreements with them to understand their needs.
Mhm.
We have partnerships with research institutions both here in the States and over in Europe. One of the great ones that we've joined is like LSU here, Louisiana State University. It's actually drilling a CO2 test well. So they're going to drill the well on site and facility so we can test all the equipment and fluids there. There's similar ones over in the North Sea. So it's really fun to be in these collaborative ventures with, these guys. And then lastly, with the operators, what we've done is launched our own joint industry project that I'm actually about to fly to Aberdeen next week to do the first workshop at. And the idea is we're going to bring everyone to the table that has storage needs, that has these projects in their timelines. We're going to figure out like what does the system need to do? What's the consensus on the risks here and the challenges? Because we have the electrical CO2 enabler design, we're building the first one, and prior to building it, I'd love to make sure we're all got the thumbs up that this is doing what we need. So that's kicking off now, and we hope to start, actually like laying steel next year or in 2027.
Awesome. Can you share any recent examples, that demonstrate how Noble is helping to pioneer, offshore CO2 handling and well control? Like, do you have a case study that comes to mind?
We do. So while we haven't done like a CO2 op like into the reservoir, we have injected CO2 from one of our rigs through Project Greensand in Denmark. Project Greensand is like one of the first carbon storage hubs that's
Mhm.
coming up into line right off the Jutland Peninsula. But they needed to do a live CO2 test injection to make sure the reservoir could like handle the CO2 as their models project. So we used one of our jackups, the Noble Resolve, brought it out to the site, jacked it up. We used, I believe it was some casing or some tubing to connect it to the reservoir downhole. They already had the wells drilled. It was pretty cool. So they actually got CO2 from like the industry in Europe and brought it by vessel to the jackup. And we brought the CO2 up, we pumped it all up, got it to the right state, and then injected it to the reservoir. Yeah.
Wow.
And so that was the first time to do one of these test injections. But these are becoming more common. Perenco in the UK just did one of theirs.
Hmm.
So you're seeing that these guys are now testing these reservoirs, making sure they're good. And then over the next couple of years, we'll get these things fully online and store millions of tons. But even with that test with Greensand, we needed to install new CO2 sensors. We needed to train our crews on how to handle CO2, what the dangers look like. We actually gave a lot of people like breathing apparatuses just in case from an HSC perspective. And then you got to flip the script, guys. Hey, if anything goes south, we actually want everyone to go up, not down. So if the alarm goes off, we actually go to the helideck. We hang out to make sure. So all this kind of the minutiae is how this started, and that was back in 2022. In the last couple of years, we've been working that problem to get to where we're at today.
That's awesome. Well, so I hear you guys are decarbonizing your fleet. Like you're you're to reduce, emissions in your own rigs. So how are you guys doing that?
Yes, so this is all enabling other people's decarbonization stories. We got
Right.
to do our own. And ours is not easy. We're one of those heavy industries as well. I mean, this thing is a floating
City.
factory island
Yeah.
city that needs tons of power to do a ton of different actions.
Hmm.
So Noble has our own goal. We're trying to reduce our emissions intensity by 20% by 2030, which is pretty handed. Pretty handed. So there's a couple different ways you go about it. The first thing you do is the same thing that we're trying to do as a macro society is just efficiency gains. Uh, you kind of do a full analysis of everything on your rig, and it's like, can we eke out any efficiency ones? A really good example is just like lights.
Hmm.
If you're using standard incandescent light bulbs, you can switch to an LED. That thing is like, what is it? I don't know the percentages, but it's like 20% more efficient. And that's a really easy one. It's just like right off, you can pick that one off the tree.
Right. Yeah.
So we're doing that from the top down. Beyond that, we're looking at behavioral changes. Especially when it comes to like how many generators do you need running? How
Hmm.
much energy does the system need? And then the last thing to highlight is we are looking at kind of like the longer moonshot options, specifically around like alternative fuels. So if you guys are, your learning audience is in the know,
Hmm.
sustainable aviation fluids,
Yes.
biodiesels, biofuels. We've actually done a campaign where we use 20% biodiesel of the overall fuel component. And
Hmm.
these things are great because if you do that, you've reduced your emissions by 20%. So we've been working with the regulators on that, and we're kind of ready to go. We're just working with our partners on that for the journey. So those are the kind of the different tools in our tool belt.
Looking ahead, how do you see offshore drilling and carbon storage evolving together over the next decade, let's say?
Well, this is the decade where like talk
Yeah.
actually hits the road. So there's real projects getting real wells being drilled. What we
Hmm.
imagine for the next 10 years is you'll have an ecosystem where all the initial projects will actually have drilled wells and will be active. And so really the kind of the three tier regions here, you'll see wells in the Gulf of America probably be drilled and active. The Gulf has a lot of onshore storage, so we just think there will be a couple wells in that kind of industrial baseline. You'll see carbon storage hubs active in both the UK, southern North Sea, and the Norwegian sector. Already, Project Northern Lights has already injected its first CO2, and they're already scaling with future phases coming along. And then you'll see some carbon storage hubs active in Asia Pacific. Malaysia has a ton of work. Australia is doing what they're doing. So I think you'll actually start to see the beginnings of their framework of what that carbon storage hub ecosystem is going to look like. So within 10 years, all of a sudden, this is going to be a real thing with
Wow.
real tonnage being stored, hopefully storing north of 10 million tons per annum, all offshore. So it's going to be pretty exciting.
It is. It's really exciting. And thanks so much, Zach, for joining me today. I really enjoyed talking to you and giving me a bit of a lesson on carbon storage and how it has to do with offshore drilling. And it's fascinating stuff. Thanks for sharing everything with me.
Oh, thanks for having me. It was a really great time to chat, and no, it's pretty fun to talk about one of these really unique technologies.
That's it for today's episode. A big thanks to Noble for sharing how their team is bringing offshore skills into the carbon storage era. It's clear that drilling and decarbonization aren't separate stories, they're becoming part of the same one. If you've enjoyed this conversation, be sure to follow the podcast for more voices leading to the energy transition. I'm your host, Maria McGowan. Thank you for joining. See you next time.